All right, students, welcome to Wednesday, April 22nd. If you're watching this on the day it's assigned, welcome to Topic 8, Day 1 of Topic 8, the last topic in this book, the last topic we'll be going over this year. And I hope you're ready. I hope you're buckled down. I hope you've got some notes in front of you. We'll be taking some notes today. I hope you're ready for this concept. On this concept and with these videos, remember, you can pause, skip ahead, repeat what's needed. I've taken some prep time to try to understand the best way to explain this to you, and maybe to prove that to you. I've got notes all over the place and post-it notes everywhere, and I've got a book over there, and I kind of been all over the place. They trying to figure out the best way to explain this to you. So here we go. The video is going to be a little longer than normal, but just stay with me, and if you understand something, just move on, and then I'm going to work through some of these problems, and we'll see how you do on today's quiz. Hopefully you'll do well. Okay, here we go. Have some notes out. And on these notes, get me out of the way. Woo, sorry, goodbye. I'm gone. On these notes, write this down. Hit pause until you've got it written down. The scale is simply an original item represented by something smaller. So pause now and write that down. An example of this is an airplane. You've got an actual airplane, but some might have a model airplane. And in your book, it says it's 240 feet and represented by 15 inches. Well, how can you represent the relationship between those things? Well, we're going to talk about the different ways you can represent on a scale factor today. One way is by a proportion. So you'll be wanting to write these down. You can wait until I set them all if you want, write them down later. But you set up a proportion where for the scale, there's an actual to the model, actual amount to the model amount. And then there'll be numbers here given to you that you have to solve one of them. That's one way to do this. Another way is by talking about the scale factor. If something is increased by a factor of 5, you put that scale factor 5 there. Another way is by equations. And another way is by drawing a picture that we'll be doing later. I'm just wanting to show you these. We're going to go through each of them. We're going to discuss them each, but feel free to hit pause and write these notes and get these written down, and then I'll explain kind of what I'm talking about. Okay, here we go. For example, how could you represent the relationship between the model of a plane and the actual? Well, let's see. If the actual is 240 feet, and that is equivalent to 15 inches, that's one way to represent the scale factor for that airplane. That's one way to write a fraction, a proportion. If someone says, well, they might give you some questions here on how to solve it. What do you notice about the relationship between the model of the plane and the actual plane? You can see different things. You can write different things there if you choose to write them. I'm just wanting to show you the beginnings of a proportion, because the whole key to all of this that I'm wanting you to use is the word proportion. Write it somewhere. That proportion will guide you to every answer in a scale factor. And I've begun the proportion here. You guys remember doing proportions before, just where something is equal to something as a fraction. Okay, so here we go, solving and looking at and doing scale problems using these. A scale drawing is an enlarged or reduced drawing of an object proportional to the actual object. And you can see here where they've built in the actual proportion on page 416. They've built it. The actual amount to the scale right here, 1.5 feet equals 1 inch. And the scale, they're wanting to know, well, wait, what's the actual length if it's 6 inches on the map? And sometimes they'll give you the actual, and you have to find out the scale. The point is, building this proportion will solve all of these problems. It's just a matter of building it and putting the numbers in that are related to each other. So this 1.5 is related to the actual, and the 1 on the map is related to the 6 on the map. Just writing the proportion the same way on both sides of the fraction. For example, what's the actual width? So the actual, if the drawing is 2.5 inches. So we've got feet over inches and feet over inches, and they're using the information from above. So if 1.5 feet is 1 inch, then how many feet is the same as, let's see, we've got feet to feet, inches to the 2.5 inches. There it is. The rest of this is them solving the proportion. Some of you like to cross multiply to solve. That's fine. Some of you like to say, well, one times what is 2.5? So I'm just going to multiply 1.5 times that same one. They're solving for the W. They're going to figure out what W is all by itself. So they're going to multiply this 2.5 off of both sides. Multiply both sides by 2.5. Fill in the rest of them. So these go to 1, and 1.5 times 2.5 goes right here. And I have no idea what 1.5 times 2.5 is. 0.5 times 2.5. I hope I get 3.75 or something. Yep, 3.75. So that's the actual width. All of this work down here, you already know, you've already done. It's the setting up of this proportion according to the scale they give you. It's going to be a bit of the work for today. So just remember this proportion, you're just setting up the actual to the model and then the actual to the model. And we'll talk about the scale factor because they do one of these with the scale factor. But this scale factor that they find, well, what is it? You know, to find the scale factor, whatever this new one is just the scale factor of the old one. Well, all this is the proportion equation written differently. If I divide both sides by x over here, if I were to get y to the x over k over 1, see how that's just the proportion? When they talk about a scale factor equation in example 2, they're really just talking about the proportion written differently. And again, with equations or drawing pictures, we'll get to those in just a minute. On this example, you have to find the area, so there's an extra step here. They want you to use the scale factor. Just use the one that you're most comfortable with, whether it's a proportion or the scale factor. They found using the scale factor of 1 centimeter is 2 yards. So they entered it in to get the 16 down here. So the 16 times 2 is 32. But if you use a proportion, you'll get the same thing. 1 centimeter is 2 yards. So with this one, let's see, that 8 centimeters, that 8 goes up here, 8 centimeters. So 1 times 8 is there. So 2 times 8 is the 16 yards. So this is really 16 yards across. Do the same thing down here. 1 centimeter is 2 yards. So 16 centimeters must be, when you multiply, by 16, 2 times 16 is 32 yards. So that's 32 yards. So once you find those distance using these proportions, then you just multiply those two together and you get the area. There'll be one on the assignment where you have to find the area. There's these added steps that they try to give you just to try to make this a little difficult, a little hard. But the point is just scale factors using this proportion equation, you'll be able to solve all of them. Okay, now for the most difficult part, these examples where they have one scale drawing, and then they actually want you to do an additional scale drawing. What do they want? They've got an original and a scale, and they say, make a new scale. And they go through all these different steps to find a new scale. I just want you to understand that if you set up the pictures and label the items according to a proportion, you'll have what you need. They'll have like the original, let's say, and then they'll have a certain scale, and then they'll have a new scale. And as we draw those pictures and write each of those items on there and fill in the blanks, then we can figure out how to write the proportion they'll want us to find. They might give us this number and that number, and then they'll give us maybe this number, and they'll say, find this number. How can we do that? Well, we can fill in the rest of the information and then set up a proportion. And I'll explain it more later. Just know that these reproducing a new scale or reproducing a new amount, these are the most difficult kinds of problems today and tomorrow. And don't feel bad if it's confusing, but let's just set up the situation and see if by drawing the picture it can make sense. Here's a scale drawing, they say, the shortest side. They give you the actual, the original. Hey, they're going to do a new barn that's 2/3 of the size. Oh, what's the scale of the new drawing? Well, let's draw the pictures of the three of them. Let's have the original. And let's have the scale. And on this one, they're going to do a new barn. And the reason I want to show you the three different ways is because here there was a new scale. This is a new barn. On the assignment, it'll be a new scale. If you just draw the three realities, you'll be able to fill in the blanks and get it set up. The scale right here is 10 inches. I didn't even need to write it because it's right there, but it's 10 inches and 20 inches. A scale represents the exact amount. The shortest side is actually 150. So the original is actually 150. And then a new barn is going to be 2/3 the size. So this new barn right here is going to be 2/3 the size of the original. What's going to be the scale of this drawing right here, this drawing to the new barn? So the drawing to the new barn is what we're trying to figure out. The drawing to the new barn. Well, let's figure out the scale. To find the scale, let's see, we need something on this picture to relate it to. We've got the 10 and the 20, and we need something here. Well, they give us the 150, so can you find out what 2/3 of the 150 is and put it right there? You can. You guys know. You know how to find 2/3 of 150, or 2/3 times 150. And when you enter that into the calculator, 2/3 times, not divide, times 150, you'll get the 100. So you know that this is 100 meters. So what's the new scale of the drawing to the new barn? Well, the drawing to the new barn, it's 10 inches equals 100 meters. If they wanted that in units, you could say, 1 inch divided by 10 divided by 10. 1 inch is 10 meters. From our unit proportions we talked about before, unit just means do it in one. So often in these scales, it's going to be a 1 right here. But 10 inches to 100 meters is right, or 1 inch to 10 meters is right. Just know that when you're making this new scale or this new barn or a new item, if you draw the three items and label what you can, you'll be able to build a proportion. I didn't even build the proportion here. I found one side and I had it. I could have said 10 is to 20 as 100 is to this and solve that, but that's not what they were asking for. That's going to be the trickiest part of today's assignment. Okay, I don't even know if we're halfway done yet, so I'll try to fly through this because I know this is a lot to take in. So here we go. Number 3. Michaela is determining the actual distance, and she uses this. Explain why her proportion is the same as this. So are these the same? You can hit pause and take a look at it. And here's why they're the same. This one says that 1 inch is 4.5 inches, as 50 is to X miles. And I taught you to write the proportion, say, hey, 50 miles, the actual over the scale to 1 inch. So that's going to be the same as a certain number of miles to 4.5 inches. So there's another way to write it. You can even hit pause and take a look at these. These are all saying the same thing. Why is it equivalent? Because as long as you're comparing one item to another and compare them in the same order, this one is the scale to the scale and then the actual to the actual. As long as you write them in the same order, you can do it writing scale to scale and actual to actual, or actual to scale as long as it's actual to scale, or the actual to the scale over the actual to the scale, like I wrote here. I wrote it showing you the way that I did it, which is the same as that. I was trying to do it different than what they did. If I do 1 inch over, here we go, 1 inch over 50 miles is the same as 4.5 inches to X miles. My point in showing you is you can write these proportions any way as long as you write them in the same order each time. So why are they equivalent? Because you're writing them, you're comparing the items in the same order. You're going to rotate them or switch them. 1 is to 4.5. Oh, they did it there. Or 50 is to X. Oh, they did it here. Watch this. What if I wrote 50 is to X as 1 is to 4.5? Does that work? Sure does. Oh, actually, it's written up here. As long as you're formulating the proportion, writing them in the same order, you're going to be fine. So what's the actual base length of a triangle depicted with the scale drawing? What's the actual base? So here's the inches. This is the scale. If 1 inch equals 2 meters, well, I'm showing you the actual. So if 2 meters equals 1 inch, there's the scale. And again, if you wrote it differently, you can write it differently. That's fine. 2 meters is 1 inch. Okay. Well, then let's see the actual base. Here's the base. You got to compare the same thing. So if you have inches down here, you have to put inches over here. 2.5 inches there. What's the actual number of meters? And then you just solve that proportion. Maybe as I'm thinking this through, how can I shorten this video? Maybe not by doing so much of this work, you can just work it out. Work it out the way you want, whether multiplying the 1 by that or the 2 by that or cross multiplying and dividing. Either way, you're going to end up with the x. The actual x is 5 meters. Again, whether you take 1 and times it by 2.5, so times it 2 by 2.5, or cross multiply. Take a second and try to work out number 5. Hitting pause. Okay, if the actual is 2 meters to 1 inch, and you might have written the proportion differently, then let's see, what's the area? Let's see, the scale. This is 1 inch, so that's 0.75 inches. So it's the actual meters right here. Well, the meters, let's see, that's, X right here. 1 times what is 0.75? Oh, well, times 0.75. Or if you multiply those two together and then cross and then reduce, you've got that it's going to be, this X is 1.5 meters. So this right here is 1.5 meters. There you go. If they were asking for the area, they want the area of this square window. So it's 1.5 there, it's 1.5 here because it's a square. You multiply those two together, you'd end up with the area, 2.25 meters squared. But again, setting up this proportion is the difficult part of this. Number 6, setting up the proportion on number 6. 30 miles on a map is a 2-inch line. Okay, so we're starting with the proportion. 30 miles is 2 inches. If the map is enlarged 3 times its size, what's the new scale? Whoa, so this new scale is going to be 3 times. Oh, so instead of 6 inches, the scale is going to be 3 times that. So that's 6 inches. Now be careful on this, it's still 30 miles. I'm saying proportion. They're wanting to know what the scale is if 6 inches is 30 miles. If 6 inches is 30 miles instead of 2 inches being 30 miles, what's the new scale? Well, 30 divided by 6 is 5 miles equals 1 inch. That's when I could have shown some pictures on that. On this one where they're multiplying just the scale. Could be confusing you a little bit on that one. I apologize for that. I'm 20 minutes in, huh? Oh, this is going too long. It's going to be a long day, guys. On a map, 1 inch is 5 miles, and 2 cities are 8 inches apart. So write the proportion, but write it the same way. This is 8 inches, and they want to know how many miles. So 1 inch is 5 miles. So the 1 inch, let's see, 8 inches. So we have to put the 1 at the same place the 8 is because it's inches. And miles, the X is on top. So the 5 miles has to go on top as well. Now that you've built out proportion, 5 over 1 is X over 8. It's a matter of solving for X. Well, let's see. If we cross multiply, 1X equals 40 miles. Or if you did another way, 1 times what is 8? And that's 8. So 5 times 8 is X. So that's 40. Same thing here. They've given you the information on the banner. You can hit pause if you want and try to work this through. Okay, having done that, the 1 inch, and we have 3 feet, inch and feet. So what's the actual feet? If the width on the drawing is 5 inches, so this is 5 inches. So we've got it written down. 3 is to 1 as what is to 5. Solve it the way you want. Okay, that gives me 3 over 1 is W over 5. I'm just rewriting it for my own benefit. I can cross multiply. 1W is 15 feet. Writing these proportions will help you on all of these. So on 9, see if you can write the proportion, hit pause, and I'm going to write it out. Okay, 1 inch is 7.2 miles. They're actually 1.5 inches across. So what's the actual miles? Well, to get from here to here, we multiply by 1.5. So if you get there to there, do the same thing. Or you can cross multiply. And 1x is going to be whatever 7.2 times 1.5 is. $10.8 miles. So on every one of these, you're setting up this proportion and working it through. Number 10. Here's where they get you. Take a look at that. And I need a bigger piece of paper. So on this, the original blueprint, so this original blueprint has a scale of 2 inches to 5 feet. So 2 inches equals 5 feet. The family wants to use a new blueprint, so here's the blueprint 1, and here's a new blueprint. They want to do a new blueprint that shows the length of the living room to be 15 inches. So the length is going to be 15 inches on this new blueprint. If the width of the living room on the original blueprint, let's see, so width. If the width of on the original, the width is 6 inches. So let's see, this is the width is 6 inches right here, 6 inches. And the length is 9.6 inches. So the length is 9.6 inches. What are the scale and width? What are the scale and the width of the new blueprint? All right. Well, here we go. There's one that I missed that I was trying to accomplish on this. Okay, so the width of the new blueprint. So what's the W right here? What's the width on that one? Well, can we find that anywhere? Can we see how to find that width? Well, if you see that 6 is 6 inches, this width and this length and length are comparable, then you can take and write the proportion of the length. Where's my original? The 9.6 is to 15 as 6 is to something. And you can write that proportion however you want. I'm going to say 9.6 is to 15. We go there to there is the same as 6 is to this new one. Or another way you can say it is you can write it as 6 is to 9.6 as x is to 15. You can write this proportion whichever way would make most sense to you. So in working that through, using the calculator, of course, where can I put this so you can see everything that I'm doing? So I'm going to take, let's see, if I cross multiply, 6 times 15, show you what I'm doing. 6 times 15 is the same as 9.6x. And on your calculator, you're going to get 90 when you do that. So 90 is 9.6x. And we're back to these equations, this proportion work from before. What is 90 divided by 9.6? So 90 divided by 9.6, 9.375. So 9.375. That's the new width. And what's the scale? What's the new scale on this? Oh, well, 2 inches used to be 5 feet. If 2 inches is 5, I could draw the proportions for each of these. The 2 inches is 5 feet over here. So let's see, 6 inches on this one. 2 inches is 5 feet. So if this one is 6 inches, then we know that then the original 2 times 6, or 2 times what is 6, that's 3. And this is actually 15 feet. So the original width right here is 15 feet. And you can do the same thing on the length if you wanted to draw the proportion there. But what's the new scale to get from here to here? What's the new scale? You're writing this like we did on the number. Woo! We did on number on 6 down here. What is the scale factor of 15 is the original, but the width is 9.375. The 15 feet is the original, and the 9.375 is the inches. 15 divided by 9.375. The new scale is the 1.6. We have the 2 inches. 2 inches is 5 feet. Sorry. The 1.6 feet is 1 inch. This process of finding, wait, what do I compare and what do I put together? As long as you're comparing in the same direction or the same order, you're going to get it right with writing these 3 pictures. But again, this is kind of a level 4 concept in terms of taking one item and synthesizing it to another, or taking one item and applying it to another. These problems are extremely hard, but if you draw these pictures and write the proportions, it will hopefully give you some ideas. And then right here on ones like this, they're asking for the area of this. So they want you to use the proportion, and then find the area after you've done that proportion. So the scale is that 2 meters equals 1 centimeter. To find the length, if it's 10 centimeters down here, okay, that makes it kind of easy. You can work this out, 1 times 10, so it's really 20 meters right here. And then same thing here, if 2 meters is 1 centimeter, and then the width is 5.5 centimeters. You get from there to there times by 5.5, so times 2 times 5.5, you get 11 meters. So this is 11 meters. To find the area, you multiply the two together to get 220 meters squared for the area. And you can give the same action on here where they're asking for the area of the field. They're wanting you to use the equation part here. They're wanting you to use the scale factor equation, y equals kx on here. If they give you the information, you can go ahead and write it out. If you're not sure how to use that, just use the proportion. Write the equation where x is the dimension of the scale drawing. So we've got something about this x and y. X is the scale drawing in inches. So x is inches. So x is inches. That's 2 inches. And y is the actual in feet. Also, that's 5 feet. Now, how does that help us? How does that get us to the answer of writing the equation? When you cross multiply so that 2y equals 5x, we're almost to that equation that I showed you. The y equals kx with being the scale factor. So then you take the 2 divided off of the y from earlier this year in solving for the equation. So y is just 5/2 of x. 5/2 being the scale factor of the model, the representation to the actual. So what's the area of the field? Well, we have to find out what the real length and real width is, then we can go from there. So if x is the inches, so 20 inches, put 20 in there, 5/2 times 20, I mean, this is really 50 feet. I'm doing this fast to try to shorten this video. Almost lost power there. And then put the 10 in right here, put 10 in for x. So 50 divided by 2 is 25. You can work those out on your calculators by putting those in for x. Then you can find the area by multiplying those two together. The area is 1250 feet squared. These problems where they're asking you to do multiple problems, multiple steps in this problem, makes it extremely difficult, yes. Okay, 13, how many square feet of flooring are needed to cover the entire floor of bedroom 1? Well, you can see here that there's these little 6 squares. They give you the scale. They're asking for area, how many square feet, how many feet squared. They're asking for area. And then in this drawing, you can see there's these 6 squares that they have. Well, if the 4 feet is 1 inch, then the actual, because we're going to get to the square feet after we figure out what this actual is, that's 4 feet. So what? How many is this actual? It's 1 inch. How many is this? 1, 2, 3. This is 3 inches. They're 1 inch apart. So they're 3 inches. So what's the actual number of feet here? You can work out the work. Go ahead and hit pause if you want. And you get the 12 feet there. So this side is 12 feet. And then over here we have these 2 inches. So 4 feet is 1 inch. And we have these 2 inches across. So 2 inches. Go ahead and work out the work on that one. And you get that on this one times 2. So 4 times 2 is 8 feet. So this side is 8 feet. What's a square feet? Well, it's 12 times 8. So that's 96 feet squared. 14 again, you can try to set up a proportion on that one. There's a number of ways you can set it up. Give it a shot. Go ahead and hit pause. And then I'll show you some possible ways to set it up. Okay, they tell you the actual distance is 200 meters. So there's one way to start setting up the proportion. 200 meters is 1.9 feet. They want the actual distance. What's the actual number of meters? What's the X number of meters if on the map it shows 3.8 feet? Now you might have written that differently. You might have written, well, wait, I can just compare these two. I can just say 1.9 is to 3.8 as 200 is to whatever this actual distance is. As long as you're comparing them in the same order, you can use these proportions however it works out. And then when you multiply those, cross multiply and divide, you'll get that X equals, and I don't know what it will be, so I'll work it out here. It's a lot of numbers to work on. You might already see that, oh, I'm just timesing by 2, so I'm just going to times that number by 2. But if you can't see that, we can cross multiply 200 times 3.8. Times 3.8, and then divide by 1.9. However way you work that out, you'll get the 400. But if you were able to see, wait, this is just double. I'm just going times them by 2. So you can just times that number by 2 if you're able to see proportions quickly. Okay, 15. This horrible set of words. If you go ahead and pause and read that, that might help you out. I'm going to draw a picture here to show you what's happening. They tell you that 2 inches, well, 33 miles is the same thing as 2 inches. And the length of the the highway on the map is 6 inches. Oh, okay, so the actual, we just know this, the actual freeway is times 3, so times that by 3 is 99 miles. Oh, that's not what they're asking. They're saying there's 9 rest stops, equally spaced, with 1 at each end. You're making a new map with 1 inch equals 30 miles. How far apart? Okay, well, let's draw this picture. We've got the highway. There's 11 rest stops with 1 at each end. So 1 and 1. And then there's 9 more in here. Equally spaced. You're making a new map with a scale where 1 inch is 30 miles, where 1 inch, well, I've been writing the actual on top. 30 miles is 1 inch. How far apart are the rest stops? So what's this distance right here? Well, you'll have to be able to see how many sections it is, and don't say 9, count how many sections there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there's 10 sections. So how far is each section? The whole map is 99 miles. The whole map. The whole highway is 99 miles. So how much are each of these sections? Well, if there's 10 of them, then they're each whatever 99 divided by 10 is on your calculator, you'll get each 9.9 miles. So 9.9 miles, the actual, will help you know how many inches apart they are. And then you can cross multiply and divide, or you can say, well, 30 times what is 9.9. If I cross multiply, 30 x's are 9.9 miles. Divide both sides by the 30. So x becomes 0.33 if you work that out on your calculator. 9.9 divided by 30. How far apart are they? 0.33 inches, or a third of an inch. This is a lot. This is a lot to handle, and in one day, I know. We could do that, but I might just tell you. I think I'll just give you the answer to this at the end of this video. You can look down to see what the answer is, to see if you're able to do it correctly. Try it a couple different ways if it doesn't work out first, and then work on that quiz at the end here. I know this has been a long day. They're not always going to be this long. It's a hard concept, but if you just know and just remember and just consider, the proportion is how you can find the scale. This proportion is what will build you into everything that will help you solve the answer. They're just going to give you different question marks here, different variables, and you just have to find the one that works. From that, you can build the scale factor, you can build the equations, and you can draw the picture. Thanks for staying tuned. This has been tough, I know. Well done.